Hey everyone, today we're going to see how incredibly fast it is to build a custom data connector for the Intugle library using an AI coding assistant like Cursor. Our goal in this video, a fully functional SQLite connector built in minutes. First, let's head over to the Intugle GitHub repository. We'll fork it to our own account. This is the first step in the contributor workflow, allowing us to raise a PR once the connector is built. Now we'll clone our forked repository to our local machine and open it in Cursor. Great, now that we have our workspace open, let's open a new terminal and run UV sync. This will sync all our dependencies. You might need to install UV for this. So the next step is to activate Intugle's vibe coding capabilities by starting the MCP server. This allows Cursor to understand and interact with our project's context. So let's enter UV run Intugle-MCP. You can also head over to the Intugle's docs to get the MCP server configuration for Cursor. Let's copy that and let's head over to the settings in Cursor, go to Tools and MCP. I will just delete the existing one I have and I'll just add this configuration. Great, now it's connected. Now for the magic, we'll ask Cursor to implement a new SQLite connector. We will use the Intugle vibe / command and tell it to create a connector. Great, now watch as Cursor instantly generates the required files. The models file for configuration, the SQLite.py for the adapter logic, and it updates the factory and also the Py project for registration and dependencies. This automates connector implementations, letting us focus on building the semantic layer for our specific data source. So Cursor has finished and it has given us instructions on how to set it up. As you can see, there's a profiles YAML which we need to set up, and it has also given us instructions on how we can pass in our tables as inputs using the dataset module. So as you can see, I have already copied my healthcare database and my .env file, which contains the environment variables for our LLM content. So let's go ahead and create our profiles YAML file, and this will contain the path to the SQLite file as shown by Cursor here. We'll just copy that and we'll just update the path. So instead of creating a notebook from scratch, we'll copy one of the existing Quick Start notebooks and adapt it for our SQLite connector. So in this case, I'll be copying the Quick Start Healthcare notebook. Alright, let's head over to the LLM configs. In my case, I will be just importing it from the .env file. Feel free to go ahead and update these variables depending on the LLM configs you guys are using, and check out the Intugle docs for more information on how to set this up. So here let's change the type to SQLite, and instead of path we'll be passing in the identifier, which will be the name of the table we want to pass to a semantic model. So before continuing, we have to install the optional dependencies that are required by SQLite. So let's do a UV pip install and put the optional dependency as SQL. Great. Now let's run our notebook and see what the results look like. So as you can see, it has started profiling the different tables. It's generating glossaries, it's predicting links. So we'll give it a couple of minutes for it to finish. Great, now that it's done, let's see what the results look like. We have the link prediction complete and the business glossary is complete as well. So let's pick one particular table, the patients table. You can see all the profiling metrics for that particular table, including the business glossaries, what was the data type that was identified, was it a dimension or a measure. And if we scroll down, we can see all the links that were predicted by the library. And we can also visualize them in a neat knowledge graph. Very cool. And all of this is actually stored as YAML files under the models folder. So the semantic search also seems to be working fine. And here is a small data product declaration. We are just taking the patient's name and their claims and just sorting it. And let's see what that looks like. Now remember, all of this is working with your SQLite database. Even this data product is also being stored inside your inside your SQLite file. Alright, the last step is to commit our changes and raise a PR. So let's just commit these changes. We'll exclude the notebook and the database for now, and we'll just push it to our GitHub. So if you head back to your GitHub account, you will see that there is a banner now to raise a PR. Let's click that. Just make sure the base repository is Intugle's data tools. You can fill up the template and you can raise a PR if you have implemented a custom connector of your own. And we'll review it and you can be a contributor as well. So thanks for watching. So we've seen that in under 5 minutes, we've leveraged an AI coding assistant to kickstart a custom Intugle connector and verify its basic functionality. So this vibe coding approach drastically speeds up data integration, allowing you to extend Intugle to any data source with unprecedented efficiency. Thanks for watching, and join our Discord channel if you're interested in updates.